plus root b into a minus root b. So a times a squared minus a root b. A times a plus a root b minus square root of b squared. So that is it. So we have a squared. This cancels this. So we have minus b. So this is the answer. So automatically, that means a salt and its conjugate, the product of a salt and its conjugate will never be a salt. And that is what has been justified with what you have on the board. Now, we are to consider example 4, which is shown in figure 1.1d. And this is figure 1.1d. We have two questions here. Simplify A and B. So we have to simplify A and B. If we are to look at A, we have 1 over 3 minus 2 root 2. Then in this first case now, we try to look for the salt. The salt here is 3 minus 2 root 2. Then the conjugate of this salt will now be 3 plus 2 root 2. So we are meant to take the fraction of that by itself. Is the fraction by itself. Then we now use it to multiply the original salt. And this is the original salt here. So we have 1 over 3 minus 2 root 2 times 3 plus 2 root 2 over 3 plus 2 root 2. This times this, we have 3 plus 2 root 2 over, this times this we have 9. This times this we have plus 6 root 2. This times this we have minus 6 root 2. Then this times this we have minus 4 root 4. So we have minus 4. So that would be the, then if we move on here, if we simplify this, we have 3 plus 2 root 2 over 9. This can cancel this. Then we have minus 4. Root 2 is 2. Root 4 is 2. So automatically we are going to have 3 plus 2 root 2 over 9 minus 8. And that will be 3 plus 2 root 2 over 1, which is equal to 3 plus 2 root 2. So that's the answer to the A part of these questions we have in figure 1.1d. Then in the second case, we have 2 root 2 minus 3 over 2 root 2 plus 1. The conjugate here will definitely be 2 root 2 minus 1. That's the conjugate. So we are meant to multiply, take the fraction of the conjugate, which is this. Take the fraction of the conjugate, this is the fraction. We use it to multiply the original salt, and that will be 2 root 2 minus 3 over 2 root 2 plus 1 multiplied by 2 root 2 minus 1 over 2 root 2 minus 1. So we use this to multiply this. This times this, 2 times 2, 4. This times this, that will be root 4. This times this, minus 2 root 2. This times this, minus 6 root 2. This times this, plus 3. Over, this times this, we have 4 root 4. This times this, we have minus 2 root 2. This times this, we have plus 2 root 2. This times this, we have minus 1. So that's what we're going to have. So if we simplify this now, we have 4 root 2, root 4 is 2. So we have 4 root 2, 4 into 2 rather. Minus 2 root 2, minus 6 root 2, that's minus 8 root 2 plus 3 over this one, 4 into 2. This can cancel this, then we'll have minus 1. So automatically, we're going to have 8 minus 8 root 2 plus 3 over 8 minus 1. So that will give us 8 plus 1, 8 plus 3 rather, 11 minus 8 root 2. And this one will give us 8 minus 1, 7. So this is what we're going to have, which can be written as 1 over 7 into 11 minus 8 root 2. And that is our answer. Now, we are to talk about equality of sorts. What do we really mean by equality of sort? If you are talking about equality of sort, I can use this example: A plus root B equals to C plus root D as an example to justify. If you have A plus root B and C plus root D, if these are sorts, automatically before these two sorts can be said to be equal, then A must be equals to C and B must be equal to D. That is the only condition that can make these two sorts to be equal. So that is what is meant by equality of sort. Then example 5 is shown in figure 1.1e, and that is what you have on the board. Find the positive square root of this. So if you are asked to find the positive square root of this, we must understand that we have two scenarios to this. When you have root A plus root B all squared, we will have A plus B plus 2 root AB. That's the, when you expand this, you have this, and that is not far-fetched. That is not far-fetched. This on this, you have this. This times this, you have this. This on this, you have this. It's not far-fetched. Then the second one is A minus root B all squared. This one too will give us A square. I say A square. A plus B minus 2 root AB. Now, if any question is designed like this, the first thing we have to pay attention, we have to make use of these two concepts. But a condition will be given that will determine whether it is the A, that is the first concept, or the second concept that will be applied. Look at the question. 49 minus 12 root A. You can see that the one that has a negative here is the concept 2, which is this one. So that means we are meant to apply this. Then what do? We just write A plus B minus 2 root AB. Is, you are comparing it with 49 minus 12 root 5. Now, by comparing the coefficients, we will discover that A plus B will definitely be compared with what? 49. That's equation 1. Then we have minus 2 root AB, which will be equals to minus 12 root 5. That's, we can simplify this before we name it. 2 here 1, 2 here 6. So automatically we can say root AB is equal to 6 root 5. That's equation 2. So in this, we are having two equations in all. So equation 1 is standardized, so you can still leave it that way. It's standardized. You have this 49. Then equation 2 is what we have to standardize. And we can only standardize equation 2 by taking the squares on both sides. We are meant to take the squares on both sides. That means we square this and we also square this. When we square this square will remove this square root. We have AB. This one will be C square root 5 square. This square will remove this. And we have AB to be equals to 36 times 5. And AB, 36 times 5 will be 5 times 6. That's 0. That's 30. And this, that's 180. So we have equation 3. Then combining equation 1 and 3. We are meant to combine where is equation 1? Equation 1 is A plus B, which is equal to 49. And equation 3 is AB equals to 180. So we are meant to use the method that is known as substitution. substitution method. This is simultaneous equation by the use of what? Substitution method. If I want to use substitution method, what I need to do is I will let my A to be from 1, from equation 1. I can deduce that my A will definitely be 49 minus B. So anywhere I see my A, I will replace it with what? 49 minus B. So I substitute this into equation 3. I want to substitute this into equation 3. So A, we have 49 minus B. B. For A is 49 minus B, then equals to 180. So I will use it to open this. I have 49B minus B squared equals to 180. So I can say that since I've discovered this, then I can rearrange this such that I have minus B squared plus 49B minus 180 will definitely give me 0. So by use of the formula, so quadratic formula now, so that means I'm meant to say that my A is minus 1, my B is 49, then my C will definitely be minus 180. And the formula says that X, which is equals to minus B plus or minus square root of B squared minus 4AC over 2A. So that's the use of the formula. And by so doing, what's my B? My B is this.